In 2024, my wife gave birth to our first son. Shortly before his birth, I was compelled to create a gift for him. A custom homemade gift that could be something he could look back on and know his daddy loves him. That led to the creation of this Stormlight Archive themed Sylphrena nightlight. It was the first 3D print project I did that I played with LED lights, and I've done several since then and have learned quite a bit. Well, last year, my daughter was born, and I wanted to do something similar. So the goal was to make a music box of sorts, though as you'll see, this ended up being nothing like a box. My thought was to have a classic wind-up music box mechanism that while it plays will cause a platform or stage to spin, while LED lights will ebb and flow in a dreamlike manner. So let's dive right in. Before I went in and started 3D modeling the actual parts, I decided I should figure out the wiring and the electronic components. The easiest way to do this would be to incorporate a simple power button that I could push that would turn on the motor and would turn on the LEDs. However, I really wanted a true wind-up music box mechanism rather than just like an audio recording or a speaker that would play when I push the button. I wanted it to feel a little bit more authentic than that. However, it's also independent of the rest of the system. So I could twist the music box mechanism and music would play, but that would not make the stage spin and it would not trigger the LED lights. And so this is where I got to play around with the idea of what is called a PZO disc. Essentially, a PZO disc detects mechanical vibrations and then can send a signal. So the plan was we glue the PZO disc right next to the music box mechanism so it can detect the vibrations of the music box. That can then send a signal to the Arduino that can then tell the nano chip to power both the motor and the LEDs so that everything is in sync. This way, when you wind up and start playing the music, we still get the spinning stage and we get the LEDs ebbing and flowing. Pretty simple, right? Well, there's a few things that we had to take into account. One, because the PZO disc can pick up vibrations, it's possible that it could pick up sound outside of the music box. So we had to adjust the sensitivity of it in the code. The other thing that helps with this is putting a 1 million ohm resistor across the two nodes of the Arduino that the PZO disc connects to. Next, we're talking about powering a motor. Something based on the research I did, you don't want to power the motor directly from the Arduino. That's just likely going to cause problems. And so instead, it was recommended I get what they call a MOSFET board. Now, the kind I got already has the resistors and stuff built in, so I didn't have to add any additional resistors to help with the flow of current. But basically, you connect the MOSFET board directly to the Arduino, and then you connect the motor directly to the MOSFET. What's cool about these Arduino Nano boards is that they have a series of pins that you connect your different systems to, and each pin can be independently programmed. So I have one running the lights, one running the motor, and one that the PZO is talking with. All right, then came time for the 3D model. This was an interesting one to model because I had to think very much about the functional purpose of all the different parts. The plan was basically to do this in two pieces. You have a bottom piece and then a top stage that's going to spin. In order for that to spin, we need a motor that has a wheel attached. As that wheel spins, it's going to push against the top piece and spin the upper stage. Essentially what I did is I designed the top stage to have a central pillar. This is going to pass through the opening in the bearing that I got. And then the bearing, of course, is what's going to connect the top and bottom together so that the top stage can spin. Now, of course, thinking through this, there's the concern too, how am I going to screw this all together? Once I put the bearing on the bottom part, there is a floor that is going to block my view to the top part, so I won't be able to attach it there. So I had to design a window in the floor so that I could still reach in there and screw things into place. This is an important piece. I designed the motor stand to have a little slot for a plastic bolt that I also 3D printed. And that was so we could fine tune how much the motor wheel pushes against the central pillar that turns the upper stage. Once all the internal parts were designed and I knew they were going to work, it was time to go to the fun, more creative design part of the 3D modeling. With the music that I picked, I loved the idea of picturing my little girl running around in the rain, chasing our 2 dogs. Now, my little girl's a baby, so she obviously can't run yet. So this is where we had a little fun with AI. And this was the image we got. It looks, I can see the similarities to my daughter, and I wouldn't be surprised if she looks similar to this as she gets older. For my dogs, I was able to take some pictures into Maker Lab through Bambu Studio. They have a 2D to 3D function on there. And I used that, and it took a few attempts, but I was able to get some good 3D models of my dogs. I decided to print all 3 of these pieces with my resin printer just to get a little bit higher quality detail. Now, once everything was printed, it was time to assemble. And this was a little bit tricky. At first I thought, do I just screw the bearing directly into the plastic? I mean, that doesn't seem very reliable. What if I crack the plastic? Well, guess what? Someone else, smarter than me, has thought of this before and has created what are called Ruthix brass inserts for plastic. This is a pretty cool idea. Basically, they are these little metal inserts that are threaded on the inside. And the whole idea here is you use a soldering iron to heat up these inserts, and then you press them directly where you want them to go. And they will adhere into that plastic as if they are part of it. Makes it for a really strong connection, but now I have a metal thread that I can screw metal bolts into, and then if something's wrong and I need to take it apart, I can. And guess what? Things went wrong, so it was a really good thing I did this. Final step was really painting. My wife helped with this a little bit. I painted our dog, she painted our daughter, and that's about it. What do you think? More? What do you think, Vienna? This was a tricky project, but it was also pretty fun to learn how to work with piezos and play around with motors. I think it's going to open the doors for some fun projects in the future. As I always say, expect the mistakes on projects like this. Expect for things to go wrong, but learn from it. The more mistakes you make, the more you're going to learn, and the better your projects are going to be in the future. It's fun to look back to this really simple LED nightlight I made for my son, and then to jump forward to see the kinds of projects I'm able to do now, just because I keep trying new things. This is a sweet little project, and while it didn't turn out 100% the way I wanted, I still think it will be a fun and treasured gift for my little girl. Things are slow moving these days with being a dad and other projects and responsibilities, but I do have a lot of ideas and a list of projects that I want to get to, so stay tuned for more, and we'll see you next time.